So now we are going to switch to analysis of low birth weight as a categorical variable. So what do? We put that annotation in our do file and our logo file. And now there are so many things, of course, I haven't added in this file, the elastic commands. But now there we are. We are going to use this section is low birth weight as a categorical variable. And as a categorical variable, it is coded as low. And so the first thing we do is to look for the proportions. So we do tab low. And there where we are. We have 59 babies that had low birth weight and 130 that had normal birth weight. Now we have to check whether if this variable is coded 01, because for logistic regulation it has to be coded 01. So code book, that variable, yes, it is coded 01. The outcome is coded 1, which is good. So if we are to do the binary, so we can do logit low with what? So with mother's age centered. And so there you go. So we now have the coefficients, and because we have the coefficients, because the model is on the natural logo scale, we are using logit. We can convert this into odds ratios by putting comma or R. Now you can see it has moved to odds ratios. Or instead of using the word logit, we can use logistic without putting the OR. And again, that will give you So what does this mean when we go to the logit? If we go back to the logit, it shows that the logo odds of low birth weight decrease by 0.05 for each increment, 1 unit increment in age, for each year increment. Now, in your bivariate, you can also do this. Instead of using age center, you could actually use the categorical age as well, so that you can have your comparisons with the now age cut. So you can see what is the difference in logo odds by categories. And you can also run this model and you put it in odds ratio scale. And you see the odds of low birth weight comparing a mother who is within 20 to 29 years to a mother who is 14 to 19. The odds of low birth weight increase by 35%. Or the odds ratio of low birth weight comparing a mother who is 20 to 29 years to one who is 14 to 19 is 1.35. Now you go back to interpretation of odds ratios in EPI, and this is unadjusted. Now you can fit the same model, by putting in so many other variables. You can put in smoke, you can put in, let me put smoke, you can put in race, and now it's going to compare whites to blacks and whites to other, because whites is coded 1, black at 2, and other 3, and starter default is the one that has the lowest code, becomes the what? The reference. And now let me put in also hypertension, and uterine irritability, but for you can put in yours, okay? And what does it show us? Now once we adjusted, look at what happens to age. The odds ratio moves from 1.35 to 1.46, but it's not statistically significant, okay? But smoke is, look, the odds of having a low birth weight baby are 3 times higher among mothers who are smoking compared to non-smokers, and this is statistically significant. Now, here we made a mistake because race is also has 3 categories, so we should now put in that and compare different races. The odds of having a low birth weight baby for blacks compared to whites, look, significant. For others compared to whites, significant. Okay? For those who have hypertension compared to those who have hypertension, significant. For those who have uterine instability compared to those who don't have, significant. It becomes meaningful analysis, you know? So you can present your analysis with the same outcome as continuous for those who want to analyze to know how much does low birth weight change, birth weight change. Or you can put it as a categorical for people who want to know the odds. I don't care about the difference in kilograms per unit change. All I need to know is how likely is it that the mother in this category will get low birth weight baby compared to this category. And another may be interested in, I want to know if this mother has these characteristics and this, what is their likelihood that they have a low birth weight, or that their weight, the weight of their baby will decrease or increase relative to a mother who has these characteristics. So all this depends on your conceptual framework, and you decide this is the same outcome, low birth weight, but we are presenting it in 2 ways, as a continuous and as a what? A categorical. Again, the choice is yours. And then you now use those things to interpret. And then you go through the methods of modeling, you test the assumptions, you test the goodness of fit and the likelihood ratio test, and all those things that were covered under applied bio 2. So this ends our sessions and shows you a typical analysis from raw data to find what? Results. Now, in this course, you are going to explore UDHS dataset or any other dataset, formulate your own question, develop an objective, then do literature review, form conceptual framework, develop a data analysis plan, select the variables for analysis, create a data analysis, an analytic dataset, and then analyze the data as you've seen from beginning descriptive statistics all the way to the final models, present those results in the tables as we've seen, and now interpret them in the narrative. Thank you. Good luck.